Hi everyone, welcome to my channel. Today I'm going to talk about things I find interesting in large language models. I'm just going to cover the fundamentals in this video. So we will explore how temperature works, what greedy, top-K and top-B sampling means, and why large language model like ChatGPT needs to forget the future during the training. So yeah, let's get started. How temperature works. In this topic, I will explain what is temperature, how do we generate tests from large language model, and why does increasing and decreasing temperature affect the model creativity. So what is temperature? Temperature is just a parameter in the large language model context. It is that control the randomness in the model output. So when you set the low temperature in Gemini or ChatGPT, the output is likely deterministic and focused. When the temperature becomes median temperature around 0.7 to 1.0, it balances the creativity. That means the outputs can be simple and also can be more creative. When the temperature is really high, the outputs can be really random and surprising. So for example, we give a simple prompt to the large language model like write the first sentence of the short story about a robot who discovered a secret. So with the low temperature, the model output is really simple and a big lack of creativity. With the high temperatures, model output is a big random surprises and more creative. So in simple terms, the low temperature means predictable, high temperatures mean creative and random. But with the high temperature, sometimes it can also be chaotic. So how do we generate tests from the large language model? For example, like we model generated I like pizza dot. What happened step by step is we give I as an input to the language model and we try to guess next token or next word like, and it concatenate back to the input. It will become I like. So you can see here, like in the iteration one, we input to the large language model I and we predict like, and then in the iteration 2 it became input became I like. It will try to guess the next token pizza, and then the input became I like pizza, and they were trying to guess the next word dot, and then I like pizza dot, and they were trying to guess the next token end of sentence. This is a special token. That means model will be stopped the generating. This is called the autoregressive generating. Why does increasing and decreasing temperature affect the model creativity? For example, we are trying to predict next token for this sentence I like. What should be the next token? So we give an input I like to the model. It will give output logis. This is raw output from the model. And now what we do is we try to change to the probability using the softmax function. So the chance of cut next token as a cut can be 50%. Dot token can be 40%, and pizza can be 5%. And then what we do is we try to do the multinomial. This is kind of like a random selection, but it respects the model output. That means the chance of choosing cut token is 50%, and the dot token can be 40%. That means when you run this sampling like 100 times, the cut can be 50 times, dot can be 40 times, and pizza can be 5 times, etc. So even though model output cut as a really high probability, but there are still chance of choosing the dot token because of multinomial is random selecting. Yeah, so you may have noted like we divide the logis by the temperatures. That is the reason why increasing and decreasing the temperature affect the model creativity. Let me explain why. And here we have temperature 1, temperature 2, and temperature 10, and these are the raw score, but to be easily understand, you can consider this as a token. So for example, token 15 has a really high probability. So in the next step, we do multinomial. That means most of the time we will mostly choose token 15. But with the temperatures 10, you can see like it is because it divides the logic with the temperature, so it suppress most of the probability together. So the chance of choosing these 3 tokens is likely equal, so that's why it increased the model creativity. For the temperature one, it will mostly choose token 15, but with the temperatures 10, the chances are mostly equal. So most of the time it can be choose this, and it can also choose this, and it can also choose this token. So that's why increasing the temperatures become more creative, more surprising. Sometimes it can be more chaotic. So let's continue to talk about greedy, Toki, and Topi. So in greedy, we choose the highest probability token. That may model predict 3 token, but cat is the higher probability token, so we choose this in the greedy decoding. In Toki, when you set Toki equal to 2, it will predict model predict 3 token, but we choose top 2 token, top 2 highest probability token. In Topi, that you can consider this as a greater than equal. So when you set Topi equal to 0.6, it will try to find 0.6. We're trying to find requirement satisfied or not, and in this case requirement is 0.6, so we try to check cat is already met the requirement, so we choose this token. But when we set top equal to 0.9, we try to check there is no token, single token greater than or equal to 0.9. So what we need to do is we need to find another token. We need to include another probability values. For example, we have a cat 0.7, so we need another 0.2, so we try to do we try to include another token, so it became 2, so it worked like that. So topic is kind of balanced between greedy and Toki. So let's talk about our final topic for today. Forget the future. That means forgetting the future as token, not actually forget the future. So in our training example, we have a sentence, I like pizza, but in our model behavior, what we want to do is when we give I to the model, it should use I to predict the next token like. After we get the I like, we should use I token and like token to predict the next token pizzas. That means even though we have all the token in the training, but for the model prediction, we only want model to focus on the present and forget the futures because of it has only the I token. When we give model I to the model, it has only information for the I. It does not know the futures token. So how do we ensure this kind of auto-regressive nature in model training? So I will explain how does attention mechanism help here. This is the high-level overview of transformer decoder architectures, but I would like to focus on multi-head attention, actually single-head attention in the next slide. So the cautious self-attentions, I would like to stress on unmeasured. So when we give I like pizza sensors to the mass attention, what will happen is it try to find the attention score by doing dot product between Q and K metric. Please know I'm oversimplifying things. So in the first dot product, when processing the I token, it will try to find how much attention should I give to I token, how much attention should I give to light token, how much attention should I give to pizza token as the I token. And then when we process the light token, how much attention should I give to I token, and also how much should I give attention to myself, the light token, how much should I give attention to pizza token, and so on for the pizza. But what we want to do is when processing I, we should give attention only on the I token, which we must forget on the like and pizza token. So when processing like, we should only focus on I token and like token. We must forget the pizza token. But for the pizza, we have all the information before, so we can focus on every token before. So how do we sure that kind of natures? That where unmeasured comes in. So how does unmeasured look like? It everything below the diagonal is 1, above is minus infinity. This is really important. So even though the exponential of minus infinity is not true 0, but PyTorch treat it as a 0 after computing this to metric. So it becomes like this metric. So it forgot the future token like in here. So for processing I, it should only focus on I. For processing light, it should focus on these 2 tokens when processing pizza, because when we process the pizza, we know all the previous token before. So yeah, so this is before the soft mode. What we want to do is how much attention score should more focus. So after the soft mode, it became like this. So when processing I should only give for I token 100%. Please note these are the random number. So when processing light token, it is become like it should focus on I token like 0.8 80%, and it should focus on itself light token 0.2, and so on. By doing this way, and by doing this way, the model forgot the futures token in the training. Thanks for watching. I hope you find this video insightful. If you enjoyed this video, please don't forget to like and subscribe. See you in the next one.